So hi guys, welcome to my channel. So today I'll be solving this GFG problem of the day, which is minimize the heights to. So let's read the problem and try to approach this. So you are given an array ARR denoting the heights of n towers and a positive integer k. So for each tower you must perform exactly one of the following operations, and that to exactly once. So means for each height of the tower you have to perform exactly one operations, and that too it is mandatory. So you can increase the height of the tower by k and decrease the height of the tower by k. You have to find the minimum possible difference between the height of the shortest and tallest tower after you have modified each and every tower. Means you are given a b c d e f elements, the height of the tower, and you have to, like, it is mandatory to perform the operations on each and every tower, and after performing the operation, what is the minimum height you can obtain from the shortest and tallest towers. Okay, so let's read the note. It is compulsory to increase and decrease the height by k for each tower. After the operation, the resultant array should not contain any negative integers. So what it is saying, like, the height of the tower is 1 and the k is given 2. So if we reduce it, so it becomes negative. So negative number is not allowed. So let's see how we can approach this. Okay, so the first thing which we are going to do is we are going to sort the array. So why we are going to sort the array? Because initially we want to know that what is the minimum height of the tower and what is the maximum height of the tower. Okay, so if the minimum height of the tower is 1 and maximum height of the tower is 10, so what is the feasible operations which we can perform among two, like minimizing and maximizing. Okay, so you all can say that by minimizing the height of the tower by k and maximizing the minimum height of the tower by k, we all can reduce the difference between these. Okay, so we increase the height of the tower of 1 by k, we can make it to 5, and if we reduce the height of the tower, like maximum tower by k, it will reduce it to 6. So we'll be seeing that whether it is contributing to our maximum or minimum or not. Okay, so we'll be updating this as 6, we'll be updating the minimum it as 5. Now what we'll be doing? Okay, so we have explored the first and last. Now what we are going to do is, so I will be starting from first index and updating till 9th index and reducing the height by k and checking that whether it is affecting our smallest height or not. Okay, now again, for so biggest element, what we are doing is we'll be updating or maximizing or increasing the height of the tower by k and checking that whether it is affecting our maximum or not. So now let's iterate. If we are standing on the first index, so the element which we are standing on is less than k, so we'll be removing this, like skipping this and moving to this. Okay, so now you all will be wondering that if I have skipped the element for this minus k, then I am also not checking this element by doing plus k. Why? Because the reason behind this is pretty clear. Because if it is not possible to reduce the height of the tower by k, then it's obvious that we are going to increase the height of the tower by k. Okay, so that's why we have skipped. Now if I have skipped, so you all can say that I will be considering by doing plus k. Now why? Because we have sorted the element, so 2 will be always greater than 1. Okay, so if we are increasing the height of the tower by k and increasing the same height by k, so there is a greater chance that this is going to contribute to our answer. So I'm doing plus k. Now again, 2 minus 4, which is negative, so I'll be moving to this. By the way, I'll be doing plus k. Okay, same plus k for that because we are skipping. Okay, 3 minus 4, which is again negative, we cannot perform the operation, but we have to perform from these two operations, so we are doing plus k. Okay, so now let's move to 4. So 4 minus 4, which is 0, so we'll be making it 0. Now 3 plus 4, which is 7. Okay, so our answer is 7 and minimum is 0. So 7 minus 0, which is 7. Initially it was 9, but we are making it as 7 because we got the minimum. Now moving to 5th index. Now 7 minus 4, which is 3, now 4 plus 4, which is 8. You all can observe one thing, that when we are standing on 4, we have reduced it by k. Now when we are standing on this, we are increasing this number by k. Okay, so if we are standing on 7 minus 4, which is 3, 4 plus 4, which is 8. Okay, so update it. our maximum become 8 and minimum become 3. 8 minus 3, which is 5, updating our new answer. Okay, now let's move to 9. Okay, now you all can see that. Okay, so previously we are reducing 7 minus 4, which become 3. Now we are, if we are standing on this index, we are doing 7 plus 4. Okay, so let's do, we are doing 9 minus 4, which is 5. Remove this and write 5. Now 7 plus 4, which is 11. Okay, so now 11 minus 5, which is 6. We already got the minimum, no need to update. Now moving to this, remember one thing again, we have reduced it, now it's turned to increase this. Okay, so now 9 minus 4 is 5. Okay, increasing this number, 9 plus 4, which is 13. So 13 minus 5, which is 8. No need to update. Now standing on this index, now 9 minus 4, which is again 5. Now increasing this again, this we have reduced, now it's turned to increase. 9 plus 4, which is 13. Okay, so let's move to next index, 9th index. Now 10 minus 4, which is equal to 6. Now 9 plus 4, which is equal to 13. So 13, now again no change. 13 minus 5, which is 8, so no need to update. And finally we got the difference in our difference variable. Okay, so this is how we are calculating our answer. So let's see the code. So initialize n array size, sorting the array complexity is n log n. That's why the time complexity given here is n log n. And okay, so difference, we are taking this largest height of the tower and the smallest height of the tower, maximum and minimum initialized. Okay, so now iterating the loop from 1, because we have to check for 1 and previous also for this. Why? Because we are decreasing our height and checking from this index, and we are increasing our height and checking for this index to be like whether it is contributing to our maximum or minimum or not. Okay, so maximizing it as maximum of array of I minus 1 plus k, we are doing same. Okay, I minus 1 plus k, if we are standing on this index, maximum of I minus 1 plus k, whether it is contributing to our maximum or not. Okay, then minimum as array of 0 plus k, which is the starting index, and doing I minus k, means if we are standing on this current index, we are doing minus 1 and checking it with 0th index. Okay, same, doing minus k and checking it with 0th index, like 0 plus k. Okay, and finally at every time we are updating it our difference. Okay, so difference is equals to minimum of difference comma maximum minus minimum, and finally returning the difference. So the time complexity of this problem is n log n. Now let's run this and let's submit it. Okay, so it got passed. So thank you for watching and having patience. So thank you.